Hi, hello, vanakkam, and welcome back to yet another episode on Little's Law YouTube channel. So today in this video, we are going to see about think time. So many of the times we have issues in setting up the proper think time. So most of the times we end up using 5 seconds as the think time or 10 seconds as the think time, and in most of the scenarios we normally don't keep or don't consider think time as the main or the high priority, and because of that we used to fall or we used to get trapped into different issues which are not the actual performance issues. So today in this video we will see what or why do we need to worry about the think time, and also issues we will face if we do not have a proper think time, and what are the areas that we have to consider while we are planning for the think time. So first we will see what happens if we do not have a proper think time. So usually the improper think times in load test or in stress testing scenarios can lead to inaccurate representations of real world usage patterns and can impact the reliability and relevance of our performance test results. And some of the potential consequences of keeping improper think times are, so the first thing is unrealistic workload. So for example, if the think times are set too high, the test may simulate a lower than expected user load on the system, and this can lead to underestimating the system's ability to handle the actual workload and may not reveal performance bottlenecks that occur under realistic conditions. And then the second consequence is overloading the system. So conversely, if think times are set too low or eliminated entirely, because many of the times I could see people are completely eliminating the think times, and the test may generate an unrealistic and excessive load on the system. So that's why I used to tell the subscribers and the friends who work in performance testing to consider or to really work on the think time part. And this can eliminating the think time actually can lead to skewed results, as the system may not be designed to handle such a rapid and continuous request, and potentially causing server overloads and performance degradation. And the third thing is the inaccurate resource utilization metric. So think time plays a crucial role in simulating how real users interact with an application. So the incorrect think times can lead to inaccurate measurements of resource utilization, their response times, and other performance metrics like CPU, the memory, and every other metrics. And the fourth failure is the failure to identify bottlenecks. So without realistic think times, it becomes challenging for us to identify the bottlenecks accurately, because bottlenecks actually manifest when there is a sudden influx of requests which is not representative of normal user behavior. And then the fifth challenge is misleading scalability information, because load tests are often used to assess the scalability of a system, right? So when we are using incorrect think time, so they can provide misleading information about how the system scales under various loads, potentially leading to incorrect scaling decisions. And then when it comes to incomplete stress testing, so stress testing aims to determine how well a system handles extreme loads, and inappropriate think times may prevent us from accurately assessing the system's behavior under stress conditions, so potentially leaving critical performance issues undiscovered. And then the last challenge is the increased resource consumption. So continuous and rapid execution of test scenarios without appropriate passes may lead to higher resource consumption during the test, which we all know, and that will affect the accuracy of performance metrics and potentially causing unnecessary strain on the testing infrastructure. So to mitigate all these issues, it's crucial to carefully choose and adjust think times based on realistic user behavior and application characteristics and any specific considerations related to our testing goals. So we have to regularly review and refine think time as we analyze the test results to ensure our performance tests accurately reflect how users interact with the system. So now we will see what are all the factors that we have to determine when thinking about when determining the think time. So the first thing is the realistic user behavior. So when it comes to realistic user behavior, we have to mimic the real world user behavior, and we have to analyze how actual users navigate through our application and incorporate similar think times to replicate a natural workload. So for example, if when it comes to realistic user behavior, we will take an example of online shopping. So what can be the think time? So if a real user typically spend around 2 minutes browsing between product pages and adding items to their cart, so we might set a 2 minute think time after the add to cart to simulate a user considering their purchase. So this can be 2 minutes, or this can be even 30 seconds, or this can be even 10 seconds. But the thing is, we have to plan, or we have to decide the think time based on the realistic user behavior. And then when it comes to the next factor, which is the application characteristics, so adjusting think times based on the nature of our application, so that's very important. For example, an e-commerce site might have shorter think times between browsing pages compared to a content heavy site. Say for example, there can be a difference between the news website versus image editing app. So users on a news website might have shorter think times, for example, like just like 10 seconds between reading articles, while users on an image editing app, an online app, might have longer think times between editing and saving images. So we have to set up the think times based on the application as well. So that's why I'm telling you the factor should be applications characteristics. And then the third factor is the documentation and stakeholder input. So we have to refer for documentation, or we have to gather input from the stakeholders who are familiar with user behavior on the application, because they may provide insights into typical user interaction patterns. So when it comes to this, take for an example, like we are using an enterprise software usage, so we have to review the documentations or consult with users to determine that on average it takes our users about 3 minutes to review a report before initiating the next action. So we have to set a 3 minute think time accordingly, or it can be even 1 minute or 2 minute or even a 3 minute. And then when it comes to the fourth factor, which is the gradual ramp up, so starting with conservative think times and gradually adjust based on initial test results. And this factor allows us to observe system behavior under increasing load and refine think time as needed. So for example, the scenario can be a social media platform. So we have to start with a conservative 15-second think time between actions during the initial load testing, and we have to gradually adjust based on system behavior by increasing or decreasing think times as needed to find an optimal balance. So that's how we can work on the gradual ramp up. And then the next and the final factor is the iterations and monitoring. So we have to continuously monitor system performance during load testing, and if we notice issues or bottlenecks, we have to consider adjusting think times to find an optimal balance that reflects realistic user behavior while maintaining a meaningful load on the system. So again, like for an example, I would say an e-learning platform. So initially we can set a 20-second think time after completing a quiz to simulate users reviewing their results, and we have to monitor the system performance, and if there are issues such as server overload, we have to adjust think times in subsequent iterations for optimization. So again, I would say there is no one size fit for all. So it's crucial for us to tailor the think time to our specific application and user scenarios, because these are some of the examples which I have told you about the web applications. But what if, because nowadays most of the times and most of the applications have adapted themselves to API. So what is the right think time for API? So determining the correct think time for API load testing involves understanding the expected behavior of users interacting with our APIs. So unlike user interface based applications like we discussed so far, API testing typically involve making a request without the human-like passes associated with user think time. So it's again a high priority on deciding the think times for the API. So what are all the factors that we have to consider? So the first thing is rate limiting and API quotas. So if our API has rate limiting or quotas, we need to account for these limitations in our think time. So and we have to ensure that our API calls align with the allowed rate limits. And then when it comes to realistic scenario consideration, so if our API consumers typically make requests in a steady continuous flow, we might have minimal or zero think time between API calls. And this is especially true for scenarios involving machine to machine communication or automated processes. And when it comes to backend processing time, so considering the think time it takes for the backend to process request, and if our API calls trigger complex computations or resource intensive tasks, we may need to introduce think time to simulate the real world processing conditions. And when it comes to error handling, because that's again a major issue when it comes to the API. So if our API consumers need to handle errors or unexpected responses, we might introduce short pauses to simulate the time it takes for error handling logic to execute. And when it comes to gradual load increase, we have to start with the minimal think time and gradually increasing the load on our API to observe its behavior under different conditions. And we have to adjust think times based on the performance metrics and system behavior observed during load testing. And even the same idea about the monitoring and iteration. So we have to regularly monitor our API's performance metrics during load testing, and if we encounter any issues such as high response times or errors, we have to iterate on our test scenarios and think times to optimize the load testing configuration. So in many cases, API load testing involves creating a constant load on the API to understand how it performs under sustained pressures, and this may mean using minimal or zero think time between API calls. However, the specific think time requirements will depend on the nature of our APIs and how they are typically used in our application or by external customers or the consumers. So with that, I come to an end. I thank you everyone for watching the entire video, and thank you so much. And until I meet you in another interesting video, it's bye bye from Vasan Shanmugam and Little's Law.